Today we'll start about kinematics and motion in one dimension. Uniform motion. What is a uniform motion? The simplest possible motion is a motion along a straight line at a constant unvarying speed. So along a straight line can be horizontal or vertical, or also it can be in different direction, but it should be a straight line. And constant means not changing. So you have a value and this value remains constant, remains same, unvarying speed. You know, speed, velocity. So if you have a motion along the straight line means it should not change its direction. And if you have a constant, unchanging speed, then we are talking about uniform motion. We call this uniform motion. An object's motion is uniform if and only if its position versus time graph. So this part is very important. So you can understand it by studying its position time graph. So this is not distance time graph. This is not displacement time graph. At the moment we are talking about position time graph. Or sometimes you can say coordinate time graph. And it should be a straight line. As you see from this graph, we have a straight line. And its slope is delta x over delta time. What is a slope? Slope means, in terms of mass, slope equal to tangent alpha. So this is alpha. As you see from this graph, this alpha, tangent alpha is constant. Alpha is constant, so tangent alpha is also constant. And since slope is tangent alpha, you can use triangle, right triangle. So the height is delta x. Delta x means change in x, change in position. And here the base is delta time, delta t. So this is again change in time, alpha. And it's obvious that there is no need to write this kind of equation at the moment. We have a straight line. It means angle is constant everywhere. So slope is constant. So you can say this is a uniform motion. So another way to understand, to study about uniform motion is just drawing or studying the motion diagram. So this is a motion diagram. This green arrow shows the size and the direction of the velocity. And as you see, these dots, they were taken during the same interval time. Let's say each 1 second. So velocity, the size of the green arrow is constant. It's 1 centimeter approximately, and the direction is same. So velocity is not changing basically. So this is a uniform motion. And one important thing that I want to tell you is about this graph, position time graph. If you have a position time graph and let's say straight line, so we know that this is uniform motion, velocity is constant. How we can calculate, estimate the velocity? So actually, slope for this kind of graphs, position time graph, equal to velocity. And the slope is tangent alpha, and this means delta x over delta time. So if you can find the tangent alpha, then it means this tangent alpha actually equal to velocity. Very simple. Because, you know, delta x over delta time in terms of mass, it's tangent alpha. In terms of physics, meter per second will give you velocity. For example, let's do this simple example, 2.1, relating a velocity graph to position graph. So position time graph given, so we need to draw velocity time graph, velocity versus time graph. So first of all, let's study this graph. We have a position, time. It starts from 0 meter, and during 2 seconds, position becomes negative. So what does it mean? It means it's going backward. As you know, let me draw it here, x coordinate, and this is a 0 position. At the beginning it was here, then after 2 seconds position becomes -4. Let's say it's somewhere here, -4. So it means it's moving backward during the first 2 seconds. We need to find velocity, and this is a straight line here, so its velocity is constant. We need to find velocity. Let's find slope. So this is a slope. In terms of mass, tangent alpha or slope equal to the opposite side, which is 4. And we need to divide by base, which is 2. So slope equal to 2. And we know that it was moving backwards. That's why velocity will be equal to -2. Negative velocity means it was moving to the left side, opposite to the coordinate. So let's say V1 equal to -2 meter per second. This is velocity during the first 2 seconds. Then next 2 seconds, starting from 2 seconds to the 4 seconds, here position remains -4. It means it's not moving. Or we can say slope is equal to 0, angle is equal to 0. So it's obvious that it stopped its motion. So let's call it V2, and this V2 equal to 0 meter per second. No motion. Further, starting from 4 seconds, ending by 6 seconds, we have again straight line. It means we have a motion, we have uniform motion. And at 6 seconds, its position becomes, it's likely 6 meter. 6 meter, positive 6 meter. So it's somewhere here. It means it went in positive direction. So velocity, we should expect positive number because it moved it to the right side. We need to find this slope because slope will be equal to the velocity. And again, we have a right triangle. The height is starting from -4, ending by 6. So this part is 10 meters. And the time from 4 to 6 is 2 seconds. So slope equal to what? 10 over 2, 5. So velocity here, let's call it V3, equal to 5 meters per second. 10 over 2, 5. Positive 5 because it's moving to the right side. So now let's draw velocity versus time graph. Velocity in meter per second and the time in seconds. So here is 0. Let's say here is -2. Here is a 5. 2 seconds, 4, and 6. During the first 2 seconds, velocity was equal to -2, and it was constant. Then between 2 and 4 seconds, velocity was equal to 0 and constant. Between 4 and 6 seconds, the velocity was positive 5, and it was constant. So this is a velocity time graph. So second question describes the car's motion. We already described it. Initially it was at 0 origin, then it went back to the left for 4 meters, then it waited for 2 seconds, no motion, and then started moving to the right for 10 meters, and position becomes 6. So here you should be careful with distance covered and the position. This graph was position, so we didn't give any information about distance. So if we want to describe it in terms of distance, during the first second it covered 4 meters, then 0 meter during the next 2 seconds, and 10 meters during the next 2 seconds. So now let's explain it more details in terms of mass. So again, we have a position time graph as shown here. Let it be SI initial position, here SF final position. So how we can relate this initial position and the final position in terms of mathematical equation. So it's simple. Final position equal to initial position plus this distance, delta S. This is distance that object covers, moves. So S final equal to S initial plus change distance, let's say. And this distance actually equal to velocity times time, or change in time. Final time minus initial time. To make it simple, usually when we solve problems, we don't use delta t, we just use t. But you should know that this is a change in time. So you can use this kind of equations. This is a mathematical equation. Final position, we are still talking about position, equal to initial position plus velocity times time, or change in time. Let's repeat quickly. Till this point, we explained about two types of graph: position time graph, and it should be straight line. Only this straight line means that this is a uniform motion, and slope or tangent alpha will give you velocity. And second type of graph is velocity time graph. Of course, for uniform motion, velocity should not change, it should remain constant, so you should expect horizontal line, horizontal straight line. It should be horizontal. And we mentioned about two equations, and these two equations are also very simple. The first one is about velocity, change in position, you should divide by change in time, or simply, usually we write like this. But in this case, this is a distance, and this is a time, change in time. But this delta S, this is a change in position, which is basically again distance. And second equation is about position, final position equal to initial position plus velocity times time. Some useful informations: distance an object travels is a scalar quantity. As you know, scalar is a physical quantity without its direction. So when you say distance, don't use negative sign in front of the symbol or number, because distance is scalar quantity, independent of direction. In what direction it moves is not important. Left, upward, right, downward, west, east, north, south, it's not important. Second one, displacement. Displacement of an object is a vector quantity. Here, direction is important because it's a vector quantity. Equal to the final position minus initial position. Final position minus initial position will give you the displacement, and you should give information about its direction. Speed is a scalar quantity, again independent of direction. Speed is velocity actually, but it's magnitude, just its number. Speed is how fast an object is going. It's always positive. It's always positive because no direction. Velocity, this is the same speed. In addition, it gives you information about its direction. So it's a vector quantity that includes direction. In one dimension, the direction of velocity is specified by plus or minus sign. Plus means it's moving to the right. Minus means it's moving to the left usually. Plus also can be used when it moves upward, minus when it moves downward. Quick example. An ant zigzags back and forth and on a picnic table as shown. The ant's distance traveled and displacement. So we need to find distance and displacement. First, let's do distance. So first, I think its initial position was 40. Yes, 40. Then it moves for so this is 15. So it moves for 25 meters to the right, to the left, sorry. Then it goes back. So it was here 15, so 15 meters it goes to the right. Then it moves to the 10 meter, so it's 20. So it's 20. Now let's find distance. So distance, first it moves for 25 meters, then 15 meters, then again 20 meters. So answer will be it should be 60 meters, but I cannot see 60 centimeters, sorry. Centimeters, so I cannot see any correct answer. So I think this question is wrong, or we used wrong number. I don't think we used the wrong number, so it started from 40, here is 50, 15, so it's 25, yes, then it goes to 30 almost, again 15, then from 30 to 10, 20, yes, so its distance is 60 centimeter. Now displacement, what was the definition for displacement? Final position minus, we should subtract initial position. So final position is, so S final minus S initial. This is displacement, yes? So final position is 10, initial position is 40, so it's minus 30 centimeter. So here we have a correct answer, minus 30 centimeters. So I think there is a mistake. This should be 60 centimeters. Instantaneous velocity. Let's talk about instantaneous velocity. What is instantaneous velocity? Instantaneous velocity is a speed and direction. So it's velocity. Velocity at single instant of time. So what does it mean? Let's say we have this kind of graph, position time graph, and this is our graph. As you see, this is not straight line, so this is not uniform motion. Instantaneous velocity, it means, for example, at certain time, this time, let's say, let it be 5 seconds, let's say, find velocity at 5 seconds. It means it's asking for instantaneous velocity at 5 seconds. So how we can find it? It's very simple. We already explained it. So since we have a position time graph, it's enough to find slope at this time, at this certain time. So how we can find the slope? Of course, it's better to zoom this part, as you see in the second graph. So if you zoom it, this point will be almost straight line. So once this is straight line, we can easily find slope tangent alpha, which is delta s over delta time, and this will give us velocity at this time, which is instantaneous velocity. Quick question. The slope at a point on position time graph, we have position time graph, and the slope. We know that it's velocity or speed. We have two choices here. If you read the options, A, speed, B, velocity, C, acceleration, D, distance, E, I really have no idea. So it's likely A or B. So speed or velocity? Actually, it's velocity, because do you remember we did one example, and slope can be negative. Negative means when it moves to the left side in opposite direction. And we put, by using this information, negative sign in front of the number, velocity, speed. So it means it gives us information about its direction, so its velocity. Another question, we have a position time graph, and the question is, at which labeled point or points does elevator have the least velocity? Least means minimum, the smallest value. So let's start from point A. Point A, this point, if you pay attention, this part is horizontal, so no slope. So velocity at point A actually equal to 0. At point B has this kind of straight line exactly at point B. So this slope is positive. So we can say VB equal to, the value is not given here, but roughly it's 45 degree. So tangent 45 degree, as you know, 1. Approximately it's 1. Meter per second or kilometer per hour, we are not sure because here there's no information about its units. And let's come to point C. As you see, point C is exactly horizontal, so slope is again 0, no slope. So velocity at point C equal to 0. So answer for the first part, least velocity is at point A and at point C, and it's again 0. And least velocity among A, B, C points is 0. Second question B, at which point or points does elevator have maximum velocity? It's B, yes? It's point B, because slope at point B is maximum. For example, here, this slope was 0. Then this slope increases, and maximum becomes 45 approximately. Then again it decreases. Let's say 40, it becomes 30 degree, etc. Then it becomes 0 at point C. So maximum angle is 45 at point B. So, and we know that this slope corresponds to the velocity. So velocity at point B is maximum. Last question, sketch an approximate velocity versus time graph of the elevator. So this part is important. Velocity time graph. Let's try to draw this graph. So initially its position was here and the slope negative, and this slope decreases. Here is negative 45, let's say approximately visually. Then slope here 45 degree becomes 0. So slope was negative, it was moving to the left, sorry, in opposite direction to the left. And after some time slope becomes 0, it stops. So we can say, we can draw this kind of graph. So it was moving negative value, let's say minus 45, it means negative 1 meter per second. Tangent 45 is 1, minus because it was moving to the left. This is point A, velocity becomes 0. It was moving to the left, but it was decreasing, velocity was decreasing. Then slope positively increases till point B, so velocity is increasing. This is point B. Then velocity decreases because slope decreases, but it's still moving to the right. Then velocity becomes here velocity becomes 0. Sorry, there is a mistake. Yes, there is a mistake. After point B, we said velocity should decrease. Velocity should decrease because here slope is decreasing, so it should be like this. It should decrease, and this is point C. Velocity again becomes 0. Another quick question. Here is a motion diagram of car moving along the straight road. So which position versus time graph matches this motion? So here, first three information, first three arrows, they have the same size, but this size is smaller than this size. So it means velocity initially it was moving slowly, let's say. Then it started moving faster. but with constant velocity. So here velocity is constant, but its value is less than here. But at second part also velocity is constant because size of the arrows is almost same. So what does it mean? Slope after zero position, let's say, should be greater than the slope before the zero position, because starting from zero position it moved faster, and in both cases we should expect zero positive slope. So here, for example, let's start from the first graph. Let's study it. You see motion starts from zero position, but we know that motion started from negative position. Zero is here, so A is wrong. B, okay, it started from negative position, then it reached zero position, then it continued. But this slope after zero position is less than this slope. So let's say this is 40 degrees, this is 20 degree, so it slowed down. But here it's vice versa, it should accelerate. C, slope doesn't change, so it never changed its velocity, which is also wrong. D, again, it started from zero position, which is wrong. And so E is correct one. As you see, this slope is smaller than this slope. Let's say this is 50 approximately, this is maybe 20. So correct answer is E. Same question, but we should draw velocity versus time graph. So this is uniform motion because here size of the arrows is same. It means velocity is constant. But this velocity is less than velocity after zero position. So we should expect horizontal straight line for both graphs, which is C. Horizontal velocity, here horizontal velocity, so velocity is constant, but after zero position, after some time, velocity should be bigger than in initial case. Similar question, but here it moves in opposite direction to the left. So in both cases velocity should be negative because it's moving to the left. And the same logic here, initial velocity is constant, and it's smaller than velocity at this part. So answer is, it should be D. So this is initial velocity, then velocity increases, but it's still moving in opposite direction. So in both cases it should be negative value.